So Lewis structures of ionic compounds, electrons transferred. I just gave you an example of this. When metals react with nonmetals, the metals say, no, I don't want to share with you, just take it. I'll give you the electrons. And the nonmetals say, oh, okay, I'll take your electrons. It'll be fine. And so in that process, we get a cation formed and an anion formed, and then we have this attraction between the opposite charges, and that's what forms the compound. So Lewis theory represents this by doing what I just did, moving the electron dots from the metal to the nonmetal. So let's look at potassium and chlorine and show how that would happen. So potassium is K and has how many valence electrons? 1. And chlorine has how many valence electrons? 7. So what's going to happen here is that potassium would like to just ditch this electron because underneath he looks like a noble gas. It's like my mom made me wear this hat because she thought it was going to be cold today, but I really want to get rid of this hat. So he's just going to take the electron off and give it to somebody else. And chlorine is, I guess, feeling a little chilly and wants the hat. I don't know. So we take this electron from the potassium, so I'm going to take that off, and that results in potassium having a plus charge. And we're going to give that electron to chlorine, and that causes chlorine to have a negative charge. And just so it doesn't get lost in the dots, we put brackets. Mastering chemistry doesn't do brackets. Any questions? So the chloride has an octet. The potassium lost its only valence electron. Underneath is the valence shell. We usually put brackets in there. Mastering chemistry has you show the charges, but they haven't figured out how to do brackets. I don't know what kind of lame sauce that is, but just know that. Don't text me saying, how do I put brackets on my ion? You can't. I told you just now. We're really short on time, so I'm going to skip that one. But let's look at this one. So we know from our study of nomenclature that barium fluoride is BaF2. Lewis theory predicts why that is. So let's look at the Lewis structures for these guys. So here's barium. Barium has how many valence electrons? 2. And we've got fluorine. Fluorine has how many valence electrons? 7. So what's barium trying to do? It's trying to unload its 2 valence electrons. And what's fluorine trying to do? It's trying to get those 2. Actually, well, no, I don't want to do all that color changing. So what I'm going to do is I'm going to erase this and give it to fluorine. Is fluorine happy now? Yeah. He's all self-satisfied and everything. I'm looking fine. And barium now has a +1 charge. Is barium happy? No. It's like I still need to get rid of this 1 electron. Where there is one fluorine atom, there is often another fluorine atom. So if we do this again with another fluorine atom, barium's going to give this electron to a different fluorine atom. This now gives the barium a 2+ charge. There's the fluorine, and it becomes fluoride and has a -1 charge. The reason that barium fluoride is BaF2 is because that's how it has to work out for all of them to get valence or octets of valence electrons. Magnesium and nitrogen. Let's look at this one. How many valence electrons does magnesium have? 2. Oops. And nitrogen has how many? 5, right? So what's magnesium going to do? It's going to give its 2 electrons to the nitrogen. So take that one off and this one off and put them over here. Now the magnesium has a 2+ charge. He's all self-satisfied. The nitrogen has a 2- charge. But is nitrogen happy? No. Where there's one magnesium atom, there's probably another nearby. So let's look at another magnesium atom. He also has 2 valence electrons. So the nitrogen's like, hey you, could you give me one of those? Sure, I need to get rid of both of them, but I'll, happy to give you one. So now the nitrogen's happy, but the magnesium's not happy. So what does the magnesium do? Finds another nitrogen. These guys are persistent. They're not just going to sit there and be unhappy. So here's another nitrogen. And this magnesium can unload its electron to this nitrogen. So get rid of that and put it over here. Now what's the charge on the magnesium ion? 2+. And this now has a charge of -1. But he's not happy. So what's he going to do? Find a magnesium, right? You see how this works? So this magnesium can unload both of his electrons to this nitrogen. That's 3-. This is 2+. So we shared and not shared, but we transferred electrons around until all these guys got happy. How many magnesium ions did we end up drawing? 3. And how many nitrogen? 2. So we got Mg, 3, and 2. What we learned before is magnesium forms a +2 ion, nitrogen forms a 3- ion, and we look at that, say the charges aren't the same, let's do the crisscross thing, and we end up with this. Lewis' theory, though, explains why that works out. Any questions? We have 4 minutes.